Hello students, myself Shamrat Pal. Now I am going to explain a topic on the types of chopper. Actually, choppers are 5 types. Class A, Class B, Class C, Class D, and Class E. So that means 5 types of circuits will be there for the choppers. Means Class A, Class B, and summation of Class A plus Class B, which will give you Class C chopper, and the summation of and the D chopper, that is opposite of Class C, okay, and the circuit summation of the Class C plus Class D, which will give you Class E chopper. That means finally we can conclude it Class A chopper and opposite of Class A, that is Class B chopper, and summation of Class A plus B chopper, which will give you Class C chopper, and opposite of Class C, which will give you D chopper, and summation of Class C plus Class D, which will give you Class E chopper. That means 5 types of chopper circuit will be there, which is very critical to recall for any purpose. So that is why we are going to present the particular approach through which we can easily identify the individual chopper circuits. That is why first, if we can understand how to recall the Class E chopper, then the other chopper circuit can be explained from Class E chopper. That is why very important to understand the first circuit. Then easily you can derive the other circuits. You can draw the other circuits just from this part and from these sections. See, first is a very simple means circuit diagram is given. One, as we know, it is a DC-DC converter. That is, the input is VS or VDC. Okay, we are using 4 switches. That is S1, S2, S3, S4, and correspondingly, obviously the 4 diodes are there for maintaining the discharging path of the inductor, as a load is RLE load we are used here. That is why the connection, just the D1 is just across to S1, D2 across to S2, D3 across to S3, and D4 across to S4. Just simple circuit is there. But how can we form the other circuits like A, B, C, D? If we can draw the other circuits, so we can easily explain the working principle or somehow working of the choppers. Actually, this classification means A, B, C, D, E, that depends on the quadrant of operation. Means which quadrant and which quadrant that can be covered by the chopper circuit. Like during Class E chopper working, which can cover the 4 quadrant operation. 4 quadrant which will cover. That is why this is called the 4 quadrant chopper. Similarly, if the chopper can cover only one quadrant or first quadrant, then we can say it is a first quadrant chopper. Similarly, for B, that is second quadrant chopper, and for C, that is first and second. As we know, the C chopper is chopper A plus chopper B, that is a first and second both, and opposite of C, that will give you the Class D chopper. That is why it will cover third and fourth quadrant. And finally, the adding of Class C and Class D, which will give you Class E chopper, which have to be cover the total quadrant, first, second, third, and fourth. Right? That is, if we can understand the operation as the drawing or sketch or schematic diagram of the Class E chopper, then we can draw the other schematic diagrams. Okay, now see, we have taken a particular section which is mentioned by this dotted line. Okay, and just cut out this line or the circuit from here, which will give you this circuit or class A chopper. See, the VS is connected to directly switch, that is why VS is connected to switch S1, right? Then S1 is connected to the load RLE, then S1 is connected to load RLE. Okay, and D4 is connected to the RLE load, and other part is connected to the negative terminal of the supply, just similar to supply and to RLE load. That means we can say this cutout section means this section which will define class A chopper, right, which is given over here. So the remaining parts which will provide you the class B chopper. So which parts are remaining? That is S4 switch, right, and D1 diode. First we have taken S1 switch and D4 diode, and for class B chopper we have to take the S4 switch and D1 diode. That means S4 switch is connected to the negative terminal of the supply, that is why S4 is connected to the negative part of the supply, right? And D1 is connected directly to the positive to the supply, positive terminal of the supply, that is why D1 is connected to the positive supply of the circuit, supply source, right? And on the other hand, then this S4 junction and D4 junction, these two are connected to directly the load. That is why this S4 junction and D4 junction both are connected to the load. That means we can say, if we consider the switch S4 and D1, which will give you the class B chopper. So we can say that is the class B chopper is the opposite of class A chopper. That is so. I will explain later why it will cover this kind of quadrant operation. Just I will be discussed just a few minutes after. Okay. Now see the class A plus class B, which will give you class C chopper. That means this section and this section, if we can add these two circuits, that means 1 and D4, S1 and D4, that means S1 and D4, which will provide you the class A chopper, then S4 and D1, which will provide you class B chopper, that means S4 and D1, and they are connected in this particular manner, and that is well reflected on class G chopper. The first part is this one. That means we can say this part, which is summation of class A and B, which will give you the class C chopper, right? Okay, fine. Next part is class D chopper, and class D chopper I just told you before, that is opposite of class C. That means we have to take this part from class E. For class C it was, I have taken this one, and now I have to take this part for class D. As we know, class D is opposite of class C chopper. That is why we can say this switch S3 is directly connected to the positive terminal of the supply, okay, and opposite part of S3 is connected to the load, as well as we can consider the D2 part. Okay, now go to the circuit diagram. Now see, in class D chopper, similarly, that is S3 is connected to the positive terminal of the supply voltage, and other part is connected to the load. Okay, one more thing is very important to notice here, that is S3 is connected to the negative part of the E. Okay, that is why that should be reflected on the diagram. This S3, okay, that should be connected to the negative part of the E. Okay, similarly we can, that is why the direction of the E has changed in this particular circuit. But from only this circuit and apart from the other circuits, all they are connected in the similar manner for E part. But as it is the opposite of the C, that is why it should be connected opposite of this direction. As the load is connected to S3 to this part, that is why E is always is a kind of back EMF, always should be opposite in the supply voltage. See, same thing is reflected as S3 is connected to the supply voltage and the load. That is why it should be always opposite polarity with respect to supply. That is why I have drawn like this. That is why S3 is sorry, it will remaining this position. It will take this position. Okay, and the other parts remaining same. That means we can say D chopper is opposite of class C chopper. So operation that should be which will give you the opposite quadrant operation. Just I will explain later. So in this way we can draw all the circuits, and which is very easy to recall or remember, right, to all the students. Just once you draw the circuit chopper E, then easily you can form the other circuits through this presentation or through this way rather. Okay, now go to the operation. That means we will explain the all individuals like class A, class B, class C, class D and class E chopper. So first we are go through the circuit of class A chopper. First is class A chopper. See, in this circuit okay, before going to the operation, first please you all students first try to recall two mother things. Okay, two mother things. Unless you can derive the all the charging and discharging path, you can't show or you can't feel the current is flowing during charging or discharging of the inductor, as we are using the RLE load. As the inductor is there is a very interesting part. We know the inductor charging path and discharging path both are in same direction. And once the inductor is fully charged with respect to supply, then the inductor try to discharge. And charging and discharging path both will be same, but it has changed its polarity during charging and discharging. It's a normal property of the inductor. I think it's known by everyone. So many times I had discussed before. Anyways, now see the circuit diagram. Okay, this is a first quadrant operation. So two mother things, keep it in your mind please. Number one, all the cases try to maintain the direction of the current flow and the polarity of the voltage appearing across the load. One thing. Number two is when the switch is on, and through the switch on switch, when the load is connected to the source, then the energy should be flowing. The current can flow from source to load. Once the switch is off and there is no relation between supply and load, then the load voltage will be led by back EMF E. Okay, so I'm explaining in a easy way the first point, that is always try to maintain the direction of the current and the polarity of the voltage. See, suppose you can think once the current is flowing suppose in this direction, and when the current is flowing suppose opposite direction with respect to the reference one, then we can say it is a negative current. Okay, similarly, suppose across any load, if the voltage is suppose this one is positive and this one is negative, after certain time during operation, if it has changed its polarity, then we can say it is a minus voltage. Okay, so this is actually called the polarity of the voltage with respect to reference and direction of the current with respect to reference. Very important thing. That means what? Suppose in this particular case, we can assume the direction of the current for all the cases. Suppose left hand side to right hand side is the current is flowing across load left hand side to right hand side. So this is a reference of direction current. If the current will change, suppose in opposite direction, then it should be defined by minus I. Number one. As well as if the voltage is appearing the left hand side of the load is suppose positive and the right hand side is negative, suppose you can take it as a reference voltage polarity. Okay, if after, if for some operation, suppose the voltage is appearing, this is plus and this is minus, then we can replace the voltage by minus term or negative voltage. That is why the reference current direction and reference polarity of the voltage appearing across load, both are very important for explaining further, right? Okay, fine. So this is the first part. Second part is what I told you, just when the switch is closed, if there is a relation, suppose supply to load, then supply will lead the voltage, total circuit voltage. If the switch is off, when there is no relation between supply and load, then we can say, then the load voltage is led by, that is back EMF E. Okay, that means when the switch is on, then supply voltage is actual voltage. When the switch is off, then the back EMF is actual voltage. So how can it possible? See, when suppose you are trying to move any motor, okay, suppose you are giving the supply voltage, right, then the motor starts moving, okay, and suppose you are using a switch over here. When the switch is closed, then the motor starts moving due to presence of supply voltage, right? And we know when the motor starts moving, then the conductor of the armature starts cutting the amount of flux, and the flux which is developed due to presence of the field magnet, then it produces a few amount of back EMF inside it, which stands for EB, right? If the supply voltage is this one, the EB should be this one. It's a normal motoring operation. Just I want to recall it for this purpose. Okay. That means what? When the switch is closed, then easily the current starts flowing to the load or machine. Then the machine starts moving in this direction. Okay. When the switch is open, then what happened? Then the switch is working as a open circuit. That means then the current is not entering to the motor, but still the motor is moving with a rated RPM. That means then it has continued produced the back EMF, but there is no relation. That means zero voltage can be supplied to the motor, but motor itself can develop its back EMF due to its high moment of inertia and is continue to rotate. That means already it has developed the back EMF inside it. That means we can say for this particular circuit, then back EMF is the original voltage. Then the motor is working as a generator. Same thing can be applicable for all types of chopper operation. When the switch is on, then the machine is working as a motor. When the switch is closed, then the machine is working as a generator, and E is actually the leading voltage. As we know, this E equal to P phi Zn by 60A. So developed voltage and inside induced EMF voltage, actually both are defined by the same expressions. Okay. So this is all about for the thought. Okay. Now you can easily explain the all operations for quadrant purpose. As we know, the name stands for during the quadrant operation. So first, see the working of first quadrant converter or class A chopper. Okay. What happened? See, when the switch is closed, right? When the switch is closed, then what happened? Then current starts flowing to switch to the load and coming back to its negative part. Okay? Then the polarity of the inductor is this one is positive, this one is negative. That means current is flowing from your right hand side to left hand side, right? As your reference, this is positive current. That is why the current is positive. Okay. And the voltage is appearing across it. This one is positive and this one is negative as your reference. That is why the voltage is positive. Clear? Okay. Now, forget this part. When the switch is off, then what happened? When the switch becomes off, then the inductor is inductor was completely charged with respect to supply voltage Vs, right? And now when the switch remaining off, then inductor has changed its polarity. Now the inductor polarity is, this one is positive, this will be negative. Now inductor try to discharge, right, as the switch is off, then the inductor stored energy try to discharge through freewheeling diode D4. In this case, what happened? Same, the current is remaining in the same position, current flowing in the same position, and voltage appearing due to presence of inductor, that is again same, it will be positive, it will be negative. That is why current is flowing. That is why during charging and discharging, it will cover only the first quadrant operation. That is why the first quadrant converter is named, as well as the class A chopper is defined by this operation. Okay, this is all about for the class A chopper. Next, class B chopper. We know it's a circuit diagram. Okay, just the switching position has changed. This is S4 and D1. I told you before, and which has to be taken from the class E chopper. It's just opposite of class A chopper. Now what happened in this particular circuit? See, when the switch is on, what happened? See it very carefully. There is no relation between supply and load, as the diode is in reverse biasing condition. That means we can say in this particular case, assume the load voltage is leaded by the back EMF, means here the motor is working as a generator. That means what? So in this case we can say that when the switch is on, then the current starts flowing, that is from this direction to this direction and coming back to this direction, right? What happened? In this case, the inductor polarity is, this one is positive and this one is negative. Okay. In this way, the inductor gets highly charged with respect to supply voltage E. So what happened? Now the stored energy inside the load, that is what? That is L di dt plus E. There is a total voltage is stored inside the load. Now what happened when the switch is off? Now the switch is suppose off. Then what happened? Is working as an open circuit. Then the stored energy inside the inductor and plus E, that is high enough and that is greater than with respect to supply voltage Vs, as L di dt is almost like E and summation of E, that will provide you the almost greater than supply voltage Vs. That means now what happened? The stored energy inside the load, that and as well as the inductor has changed its polarity during discharging path, that is why then the stored energy across the load, that is flowing through this freewheeling diode D, then the supply voltage and coming back to its initial point. That means what? That means it is behaving like a generator and the energy is transformed from load to source. That means we can say this is a regenerative process or regenerative action. That is why in the section of the chopper I had disclosed it, that is the chopper can be used somehow for the regenerative purpose. So this is the well example for regenerative purpose. That is why the stored energy inside the load, that is feedback to the supply. That means supply will gain energy. It will regenerated process. That is why this is called regenerative action. That means in the charging path and discharging path, see it very carefully. When the inductor gets charged, then the direction was in this direction with respect to reference, that is opposite direction, because we have taken the reference direction of the current is this one. Now the current is flowing in this path. That means opposite direction. That is why current is in opposite direction. Similarly, we assume the voltage was this one positive and this was this one negative for the reference one. Now due to presence of the back EMF E, all the cases the voltage appearing across the load, all the cases that is positive and that is negative. That is why it will cover the negative. Sorry, it was my mistake. All the cases the voltage as due to presence of inductor, this one is positive and this one is negative, as we thought the reference was this one positive, this one negative. That means both are in the same direction. So the polarity of the voltage remaining same, that is in positive direction. That means during charging and discharging, it will cover the second quadrant operation, just opposite of class A. Class A, which had covered the first quadrant, here the class B has covered the second quadrant operation. That is why this is really termed by opposite of class A chopper. Clear? Okay. Next, class C, and that is a very interesting part, which is really termed by the summation of class A and class B chopper. And you know how to draw the circuit diagram, right? That is class A chopper S1 D4, and that is class B chopper S4 D1. Just I have discussed before. And the summation of this all the class A and B chopper, which will give you class C chopper. That is why, as the class A chopper and B chopper, which will cover the first quadrant and second quadrant operation accordingly, we can say the first and second quadrant converter or class C chopper. Clear? So what happened in this case? Just I recall the operation just for application of the switches. See, when during class A chopper, we know the current starts flow through S1 to the load, and in this way then the inductor polarity was positive and negative. When the inductor starts discharging, it will be positive, it is negative, right? Then the inductor try to discharge in this way. Okay, it's the first quadrant operation, class A chopper. In second quadrant operation, class B chopper, then back EMF is the leading voltage. That means then the current starts flowing in this direction. Okay, then class 4, sorry, I have just mistaken something. Okay, then this is actually the supply voltage, and which will be conducted by S4. That means what? Then the current is flowing through this path, right? Then the inductor gets charged, and the inductor polarity is this one. When the inductor tries to discharge, it has changed its polarity. Then the inductor current starts flowing through this path, right? Okay, so that means S4 and D4. Both the cases, it will cover the both operations. So this is all about for the class C chopper. Okay, now the opposite is class D, means in the later section it will cover this part. Okay, not this part. So go to the circuit diagram first. For class D chopper is a very important part, this one, the circuit diagram. And as I told before, in this case the direction of the E is always opposite. Okay, that is why first clue is as per the direction, as per the polarity, reference polarity of the load. Now due to presence of back EMF, it is positive, it is negative. That is why all the cases it will cover the negative voltage first. So all the cases it will cover the negative voltage as the E is in opposite direction. Okay, so what happened? The similar operation can be done here. Suppose when S3 is on, then the current starts flowing through this direction in this way. That means current direction is opposite with respect to reference, left hand side to right hand side. Now the current is flowing from right hand side to left hand side. That means it will cover the negative current, this part. So that means it will cover the third quadrant operation, as the voltage is negative and the current is negative. Clear? And in this particular case, the inductor gets charged up to, this is positive and negative, up to the value of Vs. Now the inductor tries to discharge, it has changed its polarity. So the inductor must be discharged with the diode D2. In this case, what? Again, the direction of the current is opposite. That is why again it will cover the third quadrant operation. Another part, when the switch S2 is closed, means on, then what happened? Then the current starts flowing from this part to this part. Then the inductor gets charged, and the polarity is, this one is positive, this one is negative. In this way, with respect to reference current left hand side to right hand side, the current direction is same. That is why it will cover the positive direction of the current. And the supply is negative, back EMF, that is why it will cover the fourth quadrant operation. In this case, what happened in this case, the direction of the current was that is why the inductor polarity was this is positive, this is negative. When the inductor tried to discharge in this mode of operation, it has changed its polarity. Suppose this is positive and this is negative. Then the inductor stored energy that is summed with this one, and what happened? It is coming back to the supply in this way. That means what? That means the stored energy inside the inductor L di dt plus E, that is high enough with respect to supply voltage Vs. That is why through the freewheeling diode D3, the inductor energy and supply and back EMF, that is just discharged through this direction. In this case again, with respect to reference current, the direction of the current is same. That is why it will cover again the 4-quadrant operation where the supply voltage is where the output voltage is negative but the current is positive. And previous case current was negative. That is why it will cover 3rd and 4th quadrant operation just opposite of class C. That is why defined by class D chopper and another name 3rd and 4th quadrant converter. Understand? Okay. Now the very interesting part of final circuit for class E chopper. I just going to show this sheet. That is class E chopper. I think it's very simple operation, as you know the all quadrant operation during class A, B, C and D, and that is wellly means superimposed in this particular diagram that is defined by the 4-quadrant converter or class E chopper, which will cover the 4 quadrant. This is class A, this is class B, this summation of these two class C, this is an opposite of class C, which will give you class D. As we know, class C plus class D, which will give you class E chopper. That is why it will cover the 4-quadrant operation. Okay. As we know, the first case was what? That is S1 and D4 for class A chopper. That is why S1 modulating and D4 was in conducting state. Because this D4 is actually was applicable for the discharging path of inductor. All the cases, see, D was applicable for the discharging path. As we are using the total circuit in a complete circuit, that is why when this part will be try to operate, then it has to be short circuited. And another mode operation, when this part try to operate, then it has to be can be short circuited. That is why this is the all cases we are applying the switching devices as well as the conducting devices are mentioned here for the 4-quadrant operation individually. For first, that is S1 modulated, which means modulating means on off the switch which has to be taken some triggering pulse with high frequency during operation. In somehow it can be on, somehow it can be off. That is why it is modulating in nature. On off nature is. That is why it is called S1 is modulating. And S2, for this application, S2 must be closed during discharging path, and it will be discharged suppose for D4 during class 1 chopper. That is why S2 and D4 is defined by discharging path, and S2 is continuously on. Okay, because I am saying you, when this part try to operate, then it has to be must on or it has to be must on or short circuit. Once it try to operate, then it has to be must on, it has to be must on. That is why when the class 1 chopper try to operate, then the switch S2 has to be on always or continuously. That is why S1 for charging and S2 and D4 for discharging. Similarly, when S4 is modulating with D2, means S4 is modulating with D2, it is already in the forward biasing condition. Okay, when the switch is on, then obviously easily the current starts flowing through this circuit. That is why D2 is always in forward biasing condition. There is no problem for making any short circuit path over there. That is why we can say S4 modulating and D2 is on, then it's a charging path defined, and D1, D2 is always on, and D1 and D2 which will provide you the discharging path D1 and D2 means which path? Then D1 and D2 which will provide a discharging path. Similarly, this operation can be applicable for the other two quadrants. That is why S3 is continuously on during class C chopper. Okay, S3 is continuously on will be modulating with respect to S4 on. Means S4 on. That means then the current starts flowing in this way. That is why S4, all the cases S4 will be on. We are modulating or on off the switch, that is S3. And S4 and D2 means S4 and D2, it will provide you the discharging path, all the cases. Similarly, same can be applicable for this part. When S2 is modulating with respect to D4, then easily the current starts flowing through this circuit. Then the current starts easily flowing throughout this circuit, suppose in this way. Okay. And D3, D4 here means D3, this one is D3 and D4 here for discharging path when the inductor try to discharge in this way. So this is very important, it's very easy to understand. If you can take a blank sheet, white paper and draw a circuit and make the all direction of the discharging and charging of the inductor and maintaining different ink or different pen, then you can easily understand all the charges, due to which we are mentioning all the conducting devices here during first quadrant, second quadrant, third quadrant and fourth quadrant operation, which will actually give you the class E chopper or fourth quadrant operation. Okay students, so thank you.